Figure 3 represents a logic circuit. Use it to answer the question that follows. So we have this logic circuit and we are taught to draw a truth table for the logic circuit. So we have our logic circuit. So to determine the correct truth table, you have to determine the types of gates that have been used. So the first thing is to know the gates that have been applied in the circuit and also how the gates operate, how they treat inputs to get outputs. For example, we know AND gate outputs 1 when all inputs are 1. So such kind of logical operations are the ones to help you to get the correct truth table. So in this case, when you look at this gate is an AND gate but with a bubble at the end. So this is normally the NAND gate. And the NAND gate just means not AND gate. NAND gate means not AND gate. Not AND gate means whatever the output AND gate gives, this one complements it at the end. So we just do the normal AND operation, but at the end we negate it. This is XOR gate. So you know how it operates. For example, XOR gate, it outputs 1 when the inputs are at different levels. So the inputs should be at different levels. If one of them is 0, the other one should be 1 in order to get a 1 at the end. Then this one now is negating the operation of XOR gate. So let's draw the truth table. The truth table will consist of how many rows? We use the formula 2 power n, where n is the number of inputs. So here our inputs are A and B. So our truth table rows will be 2 power 2, which is 4. So we are going to have now our truth table. We have A and B. So we first of all write the initial inputs. All the possible combinations will be 0 0 1 1, then 0 1 0 1. After that, very important, when you want to get the correct truth table, you can make a column of every output of each gate until the last one. For example, in the NAND gate, at this point we have A. Actually, this is at this point this part, this is C and this is D. So at this point where we have C is equals to A, B, which is the normal AND operation being negated. So you form a column for that. So you form a column of C being equal to A, B, complement. Then also for D, where D is equal to AB, A XOR B. So you form for D, which is A XOR B. And now the last one is now our Q. Our Q, which is now given by our expression C and D being XORed and negated. Or else we take this and this and we negate them. So in this case, we can simply use C and D. So our Q here will be equals to our C XOR D and overall negation because of this bubble at the end. So you form column for each output. so that you get the correct truth table. So let's do the filling up of the columns. So in this case now, our column which is C, A, B overall negation, now we don't have to refer to the diagram. We use our inputs here, A and B. So for example, we know 0 and 0 we get 1, we get 0. 0 and 0 we get 0, and this negation means we take the opposite of the output 0 to get 1. So now in that case, we have to negate what we get for the AND operation. So 0 and 0, 0 and 0 we get 0, we negate 0 we get 1. 0 and 1 we get 0, we negate we get 1. Also this 1 gives us 0, we negate we get 1. 1 and 1 we normally get 1, and we negate it we get 0. So that column we have filled it. The next column is A XOR B. A XOR B. XOR gate outputs 1 when the inputs are at different levels. So if one input is 1 and the other one is 1, this is when the one input is 0 and the other one is 1. In this case we get a 1. But in case the two are the same, for example 1 1, we get 0, and 0 0 we also get 0. So now we are considering our AB because they are the variables that are forming our expression D. So we have 0 XOR 0. Those are same inputs, so we get 0. Then the second row, they are different, so 1. The third one, they are different, 1. The fourth one, 1 and 1, they are the same, so we get 0. So that is the column for D. Now the last column, we are taking what we have gotten in the column of C, we XOR again what we have gotten in the column of D, and what we get we negate. So we are using the XOR operation, but the output we shall be negating because of the overall not sign. So for 1 and 0 we get 1 because they are different inputs, we get 1, and that 1 we negate it, we get 0 as the final. In the second row we have 1 and 1, which normally gives us 0 because they are same inputs. When we use the XOR operation, we negate it, we get 1. Next we also get 1, and the last one, 0 and 0, gives us 0 because they are same inputs. We negate it, we get 1. So now the final truth table will look like that.